I'm going to show you how physics is completely broken. What you are seeing is a bunch of YouTube channels that are all basically telling the same silly, wrong story, that the reason why magnetism works is because of special relativity. And I'm going to show you a couple of different ways that this is completely wrong and it's complete garbage, and it shows how really broken the system of science is, and this is a danger to the human race. And I'm going to show you this. Okay, because you have veritasium, how special relativity makes magnet, or how Einstein saved magnetic theory, and they got a picture of Einstein with a thinking cap on. How do magnets work? Why moving charges produce a magnetic field? And he says, no, they don't, because they're going to again say that magnetism arises out of special relativity. And this is the same thing with this person here. And I'm going to put the links to all of these channels and these videos in the low bar so you can help me comment on them. I'll explain what I mean in a moment. Okay, and another one, the hidden connection, how magnetism arises from relativity. Completely wrong. But what we're going to do, I'm going to pick on this guy right now. He pretty much says the same thing they all say, so I'm not really picking on him. He just has simpler graphics that help explain the situation. So let's go off to his video right now. Okay, let's get started here.
Magnets can seem pretty mysterious.
Nope.
Their behavior is explained by Maxwell's equations. However,
no, it's not.
It's easy to convince yourself that Maxwell's equations prove that magnets don't work.
No, it's not. Okay, all right. This is what they all do. They all believe that Maxwell's equations, I guess they were taught in college, that Maxwell's equations are the complete canon of classical electromagnetic theory. They are not. All they have to do is go to Wikipedia here, and Wikipedia says the four Maxwell's equations, including Maxwell-Faraday equation, along with Lorentz force law, which actually is the part that describes how magnets work, are sufficient foundation to derive everything. Now, that's kind of in italics in classical electromagnetism. Now, this isn't really true because you also need the Biot-Savart field model and some other things, but okay, that's neither here nor there. Where these people are taught electromagnetic theory is just beyond me. Oh, for those who don't know me, I have a master's degree in electromagnetic theory, classical electromagnetic theory. Okay, but I also propose new models because I have found many errors in electromagnetic theory over the years, this being one of the ones that make me howl at the moon. Okay, let's keep going here.
That's the hook. If you're not careful, you can easily convince yourself that magnet theory is wrong. However,
you can easily convince yourself. Never mind.
Obviously, magnets do work, so what's going on? And how does Einstein save the day? Let's dig in.
Okay, we're going to skip ahead here.
Direction of the current or against it. If the wire has no current, but the charge is moving, there's no magnetic force.
Correct.
If the wire has a current and the charge isn't moving, there is no magnetic force.
Okay, let's stop right here. So they're throwing this away now so they don't have to deal with it later. Okay, this contradicts them. The observation here is that there is no force. That's actually not quite true. If you treat this charge as just a generic charge, yes, there is no force. But if this is an electron which has a magnetic moment, then there will be not only a very, very tiny attractive force, okay, but there will also be a torque. But we're not going to talk about that right now. Let's just talk about this if it were a generic charge. If this was a generic charge, then yes, there would be no force in this case. But they're throwing this out now because if you actually apply their theory to this, you're going to get a force. And we'll show you that. And that's why they're throwing this away early, so that they can just get rid of it out of their great theory, how Einstein saved magnetic theory.
However, if there is a current and a moving charge, there's a magnetic force, and it's the same basic idea as wires. Same direction attract, opposite direction.
Okay, so remember that. Like moving currents attract, opposite moving currents repel.
Everything I just told you is right, and I've taught it dozens of times in introductory physics classes. However, now let's think like Einstein.
Yeah,
I mean, sure, we can say...
Let's skip ahead to where this gets good here.
So, an outside observer will see stationary negative charges and moving positive ones in the wire, and the moving charge above the wire. For illustration purposes, we'll say they're moving to the right. The positive ones set up a magnetic field, and there we are. If we ask what the positive charge on the top sees...
Okay, this is a misnomer. What he's exclaiming here is that this camera is now stationary with respect to this charge. So what the charge sees is he sees, instead of him moving with, he sees him as being stationary, and in this case, the negative charge is going in the opposite direction. Okay, that's what he means here. This is kind of a misnomer, poorly written and confusing. So basically, look at it this way. We're looking at this situation as the camera moves with the moving charge.
In the reference frame in which it's stationary, the negative charges are moving to the left. The positive charges are probably still moving to the right, but slower than they appear to someone who's stationary compared to the wire. And this is where relativity comes in and the magic happens. Thus, according to the charge outside the wire, it sees the negative charge in the wire moving fast and the positive ones moving slower. Because the negative charges in the wire are moving faster, according to the outside charge, the spacing between the negative charges is contracted more than the positive ones.
Okay, and here's where I have a problem with this. So where did all this extra charge come? Doesn't this violate conservation of charge? And what if you had another charge on the opposite side of the wire going the opposite direction? Isn't it going to see the opposite effect? How could you see both different effects from two different perspectives? And how could it be manifesting here? Okay, so not only violating conservation laws, we're violating locality and causality. And this is where the tiny physicist brain people are going to say, well, it gets the right answer. Okay, let's forget the laws of physics here. Okay, and let's just look for correct answers. Correct answers. Let's just go for correct answers. Let's just do that. Let's just throw out the laws of conservation and all that stuff. Fine. It won't matter. I will still show you this is wrong.
I'll even stop the animation so you can see the effect. This means that negative charges are more concentrated than positive ones, and that means that the wire now has a net negative electric charge.
Okay, and because it's a net negative electric charge, instead of it being magnetism, they're saying it's really the electric field or the Coulomb field, depending on which textbook you use.
Know that opposites attract.
Okay, but one thing you got to remember about the Coulomb field is a radial only field. So if you use this technology, the only force you can apply to this generic charge is either going to be away or from or toward the wire. You're not going to get any other direction of force on that charge.
What happens is that while the now stationary top charge doesn't feel a magnetic force downward, it feels an electric force downward. What once was magnetism is now electricity. But either way, the force is downward. What happens if we look at the case where the charge outside the wire is moving in the direction opposite the current, at least from our point of view? Well, we do the same thing. Since we see the negative charges in the wire to be stationary...
Okay, this is confusing. So what he's showing you here is this is how magnetic force theory explains it, but the charge is moving to the left, and therefore it's being repelled. In this case, this isn't a stationary charge here. What he's meaning here is where the camera is following the charge as it's moving toward the left. Okay, and therefore, because it's moving toward the left, the velocity of the positive charges are much faster than the negative charges, and therefore there would be more length contraction here. So let's let him go on, but just know that this is a very confusing title here. That's all I'm saying.
And the positive ones to be moving, and the frame of the charge outside the wire, it sees the positive charges in the wire moving faster than the negative ones. This means that the charge outside the wire sees more concentrated positive charge than negative. Since the top charge is positive and same sign electric charges repel, the charge outside the wire feels a repulsive force and is pushed away from the wire. Again, the outside observer and the charge outside the wire disagree on magnetism and electricity, but they both agree that the charge is pushed away from the wire. So let's recap.
Okay, that's it. That's it. All he's going to do now is he's going to recap everything. And there's the problem. He doesn't go back and apply relativity to the very first case that we talked about where the charge is not moving relative to the wire. So we're going to go do that, and then we're going to do the recap. Okay, so the problem is he doesn't apply this theory going back to the condition where the velocity of the charge is 0. Because if the velocity of the charge is 0, and there's a current moving in the wire, then according to what they just got through telling you, that this should length contract here. If that's the case, then there should be repulsion even when the charge of the velocity of this exterior charge is 0. And they don't do that. They throw it away in the beginning, say, oh, yeah, well, there's nothing here. Yeah, nothing more to see here. And then they do not bother to do their due diligence and apply their crap theory to the condition where it's observed that there's no force on this charge. Okay, the only way that they can reconcile this experiment is if in the case where the charge is equal to 0, or the velocity of this charge is equal to 0, that the positive charges are moving in one direction and the negative charges are moving in the equal and opposite direction. Okay, and that is physically not true. Physically not true. But there is one guy out there who is a, I guess, electronics teacher who is making this argument that you need equal and opposite currents running in opposite direction in order to get special relativity. He corrected this to explain magnetism from electricity. I didn't go through his full thing because the charges that make up the binding of the wire have to not be moving relative to the wire. That there's no other way. You can't have this situation. Okay, so if we go back to Albert Save's magnetism and we look at the summary of what they told us, okay, we're not done yet. We're not done showing how they're wrong. So what we're going to do is we're going to use this force diagram. I call this a force diagram. Here's our wire with the current in it. Here's our charge. What this diagram means is if this charge is moving with a velocity in this direction, it's going to have a force in this direction. If the velocity of this charge is moving in this direction, it's going to have a force in that direction. Okay, that's what they say in their video. On the side here, we're looking at the end view, and we're going to use this case pretty much for the case where the velocity of the charge is equal to 0. In this case here, they're showing if we apply their theory, they have to get a repulsive force even when the velocity of this charge is equal to 0. And this is wrong. Wrong. Absolutely wrong. But this is what they claim. So this is the summary from the Albert Saves Magnetism videos. Now there is more, because if you take what Albert said, he said that the magnetic field moves with the magnet. If you take this concept of a magnetic field and apply it to the Lorentz force model. Now remember, the Lorentz force model is not part of Maxwell's equation. It is F equals QV cross B. The problem with this magnetic field model moving with the magnet with the wire, this actually violates locality. This is explained in my video series on ethereal mechanics. But if you do that, you get more forces. These are forces that are not anticipated in the Albert Saves Magnetism videos. Because if this charge moves toward the wire, it's going to experience a force going to the rear. If this charge moves away from the wire, it's going to experience a force moving in the direction of the current. Now, the reason why they don't even bother talking about these is because with their Albert Saves Magnetism model, all you can get are radial forces. In other words, forces that go away from or toward the wire. You cannot get forces that move in the direction, and that's the second part of how the Albert Saves Magnetism theory is a complete failure. It doesn't predict all of the modes of force we see with magnetism. And this Lorentz force model has been around for a long time. It gets good results. Okay, and now look at Lou Electromagnetism V5. Now this derivation is done in the video, this video here. Right now it's just for Patreon members, but it will be made public in January 2024. The magnetic force model of new electromagnetism for charge-to-charge effects is this. This is based on the pretonic field model. This is only a force model that's based on the pretonic field model. And what we do is we apply this to both the stationary charges and the conduction charges. This VSC is the velocity of the conduction charges relative to the wire. So in order to get the total velocity relative to the medium, we need to take the velocity of the source wire. But when we compute both of these effects and add them together, what happens is the velocity of the source wire drops out, and only the conduction current is required for us to compute the effect on this wire on a target charge. This, though, understand this is a vortex matrix. This division forms a vortex matrix. A vortex matrix. That's what vortex stands for. Vortex matrix. It's a rotation. In the configuration that we're doing, this will cause a 90-degree rotation. And also the magnitude's affected too. And over here, this velocity of the source wire falls out for an infinitely long wire, or significantly long wire. And so if you take the velocity of the target charge, this is going to rotate it 90 degrees in the situation we're talking about. And this is going to give us, oh, I forgot to forget that. That's a leftover. And that also gives us the same force rows that we get with F equals QV cross B. The difference being is the pretonic field moves with the medium. It does not move with the wire. And because of that, it does not violate locality. And this is the only force system that does not violate locality, causality, all of them. But now, wait a minute. What if we're not using a generic charge here? What if this is really an electron? Doesn't an electron have a magnetic moment? Isn't it like a magnet? Well, we go ask this guy.
What causes an electron to be a magnet? The short answer is, well, nobody knows.
Well, okay, so they don't know. Okay, but in new electromagnetism, in ethereal mechanics, okay, the ethereal mechanics model of the electron shows how the magnetic moment of an electron comes about. And because it has a magnetic moment, this is going to align with the force created by the line with, and I'm using the classical field lines here, but it's going to align with the classical field lines. Also, because we understand the structure of the electron in ethereal mechanics, we also detect that there's an itty-bitty, tiny attractive force. It is so small they probably would not have noticed it. And this force is proportional to the square root of the magnetic moment. And therefore, a proton would have a significantly smaller force in this case here. Now, if this current here goes in the opposite direction, this magnetic moment will flip in the other direction, and it would still be an attractive force. Okay, this is not anticipated by anybody but ethereal mechanics. This part here, magnetic moment, is known, and it is known that it'll have a torque. But Albert Save's magnetism cannot do a torque. It can only do a radial force. So this torque is not predicted by the Albert Save's magnetism theory. Okay, so if we do a wrap-up on all the forces, the F0 force that would be predicted by the Albert is wrong. It's not been observed, but Albert Save's magnetism, it must be there. Okay, Albert does not, and I numbered the forces from before, so you can go back and check out these numbers. And because we don't have a model of how an electron is a magnetic system, we cannot say how the torque comes about. Although we could probably give a pass on this one because we know that it will align with the magnetic field. So I should probably turn that one to a yes. But it doesn't really matter. Okay, but now that extra little force going down, well, because they don't have a model of an electron to tell how it produces its magnetic field, they can't theorize about the existence of this force. If I can make a video for my Patreon members and show them that this force must be here. It has to be here. There is no other way that we can have a torque without this force. So now what about violations of the rules of acquisition? Well, Ethereal Mechanics will not ever violate the rules of acquisition. My Patreon folks know I've taken year detours to come up with better theories that will not violate the rules. Okay, where Albert says magnetism violates pretty much all of these, I'm sure it violates other, and the Lorentz force model violates locality. Because you can't tell me how a current in a wire produces a field ring somewhere out in space. There is no connection to explain how 1A creates B. Where in ethereal mechanics, a pretonic field is an emission just like the waves of a boat. It's an emission. There are no static fields. Everything is an emission. And because of this guy to me is the greatest salesman. He should get a Nobel Prize for salesmanship. Everything in special relativity can be found in sound relativity. So all he did was repackage sound relativity and sell it to all you physicists as if it were something special. And look, he even called it special relativity. Okay, and I know there's going to be people out there that are going to say, well, what about time dilation and length contraction? Oh, I got you there. No. Because if you take one of these little Arduino ultrasonic transducers, one's a transmitter, one's a receiver, it's a distance measurer, and you put it here and you put a target on the other side and you bounce the waves off the target, measure the distance, you're going to get one answer. And then when you put a wind in between there, you're going to see the distance change, which would effectively mean that the time it takes for the pulses to go up and come back are going to time dilate. This is exactly Einstein's thought experiment where he derived time dilation. Okay, length contraction. Well, if sound waves held matter together, sure enough, it would length contract. It would have all the contractions. Matter of fact, we do have experiments where sound can hold matter together. And you apply wind to that, you tell me you're not going to get a change to the spacing of those droplets? You might even get contractions you never thought of in relativity. Ethereal Mechanics says there's other modes of contraction that we're not accounting for. And it just gets even better because the physicists were on the right track. And see, in the beginning, they were looking for a static medium in order to explain the propagation of light, but they couldn't find it. It didn't work. And before Lorentz and those other guys got started down the road of the dynamic medium, which is where I went with ethereal mechanics, this guy came out again and sold them general relativity, which has a fabric of space-time, which, my friends, is a static medium. It doesn't matter whether you call it a fabric of space-time, an ether, or you call it unicorn tears. It doesn't matter. It's a medium that's stationary that fills empty space. And so this guy is great. He sold you something you were already theorizing about. Now, granted, it's stationary. You really need to go to a dynamic medium to get the unification. But again, he sold you something you were already doing and making you think it was something different. This guy could sell ice to Eskimos and make them believe it's something they've never seen before. Okay, and this, because you got stuck on a static medium, you have had 100 years of stagnation. Because quantum mechanics is supposedly a model of matter, but it does not have a model of gravity. And then you have relativity, which is supposedly explains gravity, but it does not have a model of matter. You need a dynamic medium to bring all of this together. And the impasse has been going on for 100 years. Okay, ethereal mechanics unifies all the forces with a dynamic medium. And the model of an electron is basically two protons spinning opposite each other around in a circle, consuming the medium. And this ring of fire is kind of like a nuclear reactor that is closed in on itself. But I use a nuclear reactor because that's the only word we have. The energies involved in here are orders of magnitude larger than a nuclear reaction. This is the feeding of matter at its feeding on the medium. And these, because the Protons are running around in a circle. They're actually spinning up the medium. So even though the protons are not moving faster than the speed of light relative to the medium, because they're spinning up the medium relative to the stationary observer, they're moving at incredible speeds. In the electron, the protons are moving at about 500 times the speed of light. And in the proton, they're moving at about 1,400 times the speed of light, which would mean that starship travel has now an upper limit of 1,400 C. And if you've watched my other videos on my YouTube channel, I have a video that says we need to break at least 500 C in order to save the human race. Because on our planet, where there's only a limited amount of space and the human population keeps growing, there's only limited resources. Yeah, technology is going to get us so far, but there is an upper limit. We got to start moving population off the planet to save the human race, because we have all of our eggs in one basket. One nuclear war, one plague, one asteroid impact, and it's all over. We need to start getting people off the planet in large numbers. With all due respect to Mr. Elon Musk, it's not going to get done with 600-year-old Chinese rocket technology. So I need your help, because see, I went on this video to show where she made some mistakes in her math. Okay, and you can see like it's 2 weeks ago, and I have no thumbs up, not even any thumbs down, nothing. And a guy that also did something 2 weeks ago, well, he's got 528 thumbs up and 18 replies. If you go all the way down, everyone that's 2 weeks ago has got hundreds of thumbs up and lots of replies. So I went back to this site using my Ethereal Mechanics YouTube account, and my things do not even show up. Okay, that's why I've decided to go on to Twitter. Supposedly, Twitter is a place that allows you, and I don't know how to use Twitter. I don't know what, it's my head's spinning. I have no idea the proper way to use it. So this video I'm going to try to post on there. This will be the first video. I'm making this video for Twitter just to see if it truly is the place where you can say things without being shadow banned. Okay, but I'm going to be posting this on my other website. So people, do not sign up or become my Patreon member unless you have the stomach for a real quest. Okay, I am tired of the bullshit that's letting us go nowhere in this world. These physicists have no clue what they're doing, as you can see by what I presented here. And by the way, I get dibs on this planet. If there is a planet like this in the universe, this is the planet I want, as long as it's warm and tropical and there's no big sea monsters here. Okay, and thank you. No more voodoo physics.